All right, so what we're going to look at, we've looked at a couple of fair division types of things, how to divide, divider chooser method, bidding points and all that method, Nassar's inheritance procedure. So what we're going to do is we're going to look at a sort of an unfair division way of doing things. And so we're going to look at the sort of opposite of fair division. We're going to look at unfair division, which we're going to look at in the context of gerrymandering. Now, I have hinted at some ways to make things unfair in the past. For instance, right, if you're the chooser, then that's always a better scenario. Or if you understand what the parties you're betting against interest are, then you can obviously make things a little bit unfair. All right. And we've seen that in terms of apportionment and in terms of voting, how some things can be gamed as well. So we saw that quotas, when we were talking about apportionment, can change that standard divisor changing can change our quotas and change our number of representatives. And we've seen when you had sort of weighted voting that different types of quotas can make one group have very little power or one group have a lot of power. All right. So we have seen a few things about unfair practices before. So we're going to look at this particular unfair practice known as gerrymandering. Okay. Now this is a picture of one of the districts in Chicago, and it's a fairly famous picture. But basically, gerrymandering is an attempt to establish a political advantage by manipulating district boundaries. Okay? Now, one of the hard things about gerrymandering is figuring out if something's been gerrymandered or not. All right? And the whole, shape of a district. You can see that this shape of the district that I chose in Chicago, it looks quite awkward. But gerrymandering is more than just drawing things funny. Sometimes funny drawings, like that district in Chicago, may not have actually been gerrymandered. Maybe it has, maybe it hasn't. And also, nice drawings don't necessarily mean that you haven't been gerrymandered either. Okay? There's all kinds of, nice drawings that you can make which give one or another political party some advantage. Now, again, if you want to find that map that I just showed and what kind of percentages those those districts vote for, especially the one I said, you can click on this website. I'm not going to go into it, but that was a famous district in Illinois. By the way, the districts around it vote almost identical percentage-wise to the district that it was drawn in. So it may not be the case that really ugly-looking thing is gerrymandered. Maybe it is. I don't know. So instead of focusing on the maps and the drawings, we're going to focus on the numbers, okay? And specifically, we're going to assume that, we can draw it however we want, that there is a way to draw it with the numbers that we want, and then we'll go on from there. All right, so we're going to assume we have 4,732,000 voters in Michigan. And that's about how many people voted in 2012. Now, it turns out that Michigan has 14 representatives in the House of Representatives of the United States, in the Congress anyways. So if we divide all those things evenly, and that is a slight assumption. Remember, in apportionment, we didn't have to divide everything perfectly evenly, but let's assume that we're going to divide those 14 districts perfectly evenly. And we'll divide them at 338,000 people. So, in other words, if you take this 4 million number, divide it by 14, you get about 338,000 people. Now, in the past election, there was about this many people, 2,575,000, who voted Democrat. And there's about 2,157,000 who voted Republican, or at least that is for the presidential side of things. Okay? So we're going to assume that we're going to have the same votes in, let's say, an election coming up. And we want to create 14 districts of size 338,000. Okay? Again, we have this many Democrats and this many Republicans in the state, or at least that many vote. So we're going to assume that, in the next huge meaningful election, we're going to get the exact same thing. So we can ask ourselves a couple of questions. We can say, well, how could you make districts to minimize the influence of Republicans? So if we wanted to get as few Republicans possible, how could you do that? Well, if you just wanted a simple win, what you could do is you could make sure that there's just slightly more Democrats than Republicans in as many districts as possible. So, for instance, if I make a district be 170,000 Democrats and 168,000 Republicans, well, it turns out that that'd be a perfectly fine thing to do. Now, if I tried to make every district that, the numbers wouldn't quite add up right. Okay? So let's just, in this case, how many times can you make 170,000 out of this many Democrats? Well, if we did that, take 2,575,000 divided by 170,000, and you'll see that you get 15.14. So you can make more than the 14 districts. All right? So here's what I'm going to do. I'm going to make 13 districts have, I don't know, it's 168 times 13. Yeah. I want to make about 13 districts have this. Now, it's a little bit tricky here because if we make 13 districts have these numbers, then the number of Republicans won't quite add up. So it turns out what you have to do is you have to say, well, let's make 12 districts be 170,000 Democrats and 168,000 Republicans. Okay? And I do this because if you take 168,000 and you try to make 13 or 14 districts with that many Republicans, well, then you're going to go over the number of Republicans that are possible. Okay, so if you made 13, you'd go over the number of Republicans possible. Okay, so that's what we're going to do. And by the way, if we make 12 districts that way, then what we've done is we've used a total of 2,016,000 Republicans. And if you take 170,000 times 12, you get 2,040,000 Democrats. Okay. So the remaining 2 districts, let's just split those evenly. So if we have that many Democrats, that means we have 535,000 Democrats left over. So if we split that by 2, let's say we were going to put 267,500 Democrats in 2 districts. And by the way, we have 141,000 Republicans left over. Split that in 2. We'll have 70,500 Republicans in those 2 districts. So if you want to make sure that the minimizing the influence of Republicans, what you need to do is just make simple majorities with as many Democrats as you can, and then whatever and sometimes again these numbers won't add up. Here we ran out of Republicans because we're making our Republicans 168,000. All right, there are times where you could have ran out of Democrats. So here's what I want you to do. I want you to try to do the exact same thing, but the opposite direction. I want you to try to minimize the influence of Democrats. Okay, again, we still have the same numbers, 14 districts, size 338. So push pause on the video and then come back when you've calculated that out. All right, so hopefully you've done that. And again, if we want to minimize the influence of Democrats, then we want to kind of create as many, if we're talking about, if we know that they're going to vote exactly the same, we're going to try to create as many 170,000. In this case, if we want to minimize the influence of Democrats, we want simple Republican majorities. So 170,000 versus 168,000 Democrats. Okay. Now in this case, we run out of Republicans at a certain time. If you take 2,157,000 and divide it by 170,000, what you're going to get is you're going to get 12.7 about. So what that's telling us is that we can make 12 districts this way. Okay? Now, what that's done is that's used 2,040,000 Republicans. And that's used, well, take 168,000 times 12. That's used 2,016,000 Democrats. Okay. So with our remaining 2 districts, what we're going to have to do is we're going to have to split the remainder evenly. And if we do that, let me just state what I'm saying there. So in the first 12 districts, we used 2,040,000 Republicans. So that means that there are 117,000 Republicans left. And we've used 2,016,000 Democrats. And so that means we have 559,000 Democrats left. Okay? And that should make sense on that. So what we're saying is now these remaining 2 districts, each of them is going to have half the Republicans remaining. So take 117,000 divided by 2. So you get 58,500 Republicans and 279,500 Democrats in those last two districts. Now, notice something. In the previous example, when we wanted to minimize the influence of Republicans, we could have 4 districts, all of which voted Democrat. If we want to minimize the influence of Democrats, well, since there's more Democratic voters, you're going to have at least one, and in this case you have to have 2 districts which vote for the Democrat. Okay? So basically what you're trying to do in all of these is you're trying to add up all of get as many of the districts possible in your favor, and then with the remaining 2 districts, see what's left. Or in this case, 2 districts. It could be obviously 3 or 4 or whatever. Now, I will say, most times we don't want this to be 170 to 168. That's a really tight race. Okay? That's 50.3 to 49.7. And if you're a politician, you don't like that number, or you don't like those numbers. That's close to 50-50 is really hard to deal with. Okay? Because, you could swing voters either way. So if you're if you're an incumbent politician in that district, you'd much rather play it safe. You'd much rather have your district have let's say at least 70% Republican or 70% Democrat. Sometimes people would do 60 or 65 or whatever, but let's do 70 in this case. Now, 70% of people voting Republican translates to that many Republicans in the district of 338,000. And 70%, same thing with Democrats. If this was 70% Democratic seats, you'd have to have 236,600 people in the district. Okay? So let's try to play it safe in the same examples. All right, so what we're going to do is we're going to, again, minimize the influence of Republicans. But we want safe districts. We don't want simple majorities, but we want safe districts for Democrats. So what you do is you take as many 236,600, whoops, I left out a 6 there. 236,600 Democrats versus 101,400 Republicans. And you make as many districts as you can with those 2 numbers. Okay? Now, here's what I'm doing when I'm trying to see how many districts, how many times that counts. I'm taking this number up here, this number of Democrats, this 2,575,000, and I'm going to divide it by this. Okay? So take 2,575,000 divided by 236,600. And what you'll get is you'll get 10.88, or at least that's what I got on my calculator. So what that means is you could have made 10 districts have this outcome. All right? Now, if you have had 10 districts which had that outcome, that means you have in those 10 districts 2,366,000 Democrats that have been counted already. And that means as far as uncounted, that's 209,000 Democrats uncounted. Okay. So, as far as Republicans go, take that 101,400, multiply that by 10, you'll see that 1,014,000 Republicans have been counted, and one, 4, 3, 0, 0, 0. So 1,143,000 Republicans have not been counted. And so we're just going to split those evenly, the number of people who haven't been counted, in the last 4 districts. So the 4 districts remaining, take 209,000, divide that by 4. You'll see that in each of the 4 districts remaining, we'll put 52,250 Democrats, and in each of the 4 districts remaining, that means you would have 285,000.75 Republicans. Okay? So that's how we're always going to do it. We're going to say, well, how many safe districts can I possibly get? Okay, now once I've done that, how many did I spend? How many do I have left? And so all of the remaining districts, we're going to divide evenly by how many we have left. Okay? That's what's going to happen. All right, so what I want you guys to do is try to do that same thing. We're still in Michigan, and still the same numbers. But let's try to minimize the influence of Democrats, but have safe districts for Republicans. Okay? Remember, a safe district meant 70% for us, which involved 236,600, right? So, push pause on the video, do that, and then come back and see if you get the right answer. Alright, so hopefully you've done that. And basically in this case, right, we're still going to start out with, I can't talk today, 236,600. But this time Republicans, because we want to minimize Democrats' influence. And 101,400 Democrats. All right. Now, if you divide the total number of Republicans by 236,600, what you'll get is 9.11. And that means you can have 9 districts with this population. Okay, there's this type of population. So with the remaining 5 districts, we're just going to split everything evenly. Okay, now if I take 236,600, multiply that by 9, and then subtract 2,157,000, you'll see that this means there are 27,600 Republicans left for all the 5 districts. And if you take the 101,400 times that by 9 and subtract the number of total Democrats, you'll see that you get quite a lot left. In fact, 1,662,400 Democrats left. Okay? So all we have to do is divide both those numbers by 4, 27,600. Divide that by 4. And you'll see that in the remaining districts, 6,900 Republicans should be there, or 6,900. And oh, did I say that wrong? You should divide by 5. I think what I did, I divided by 4. I hit the wrong number on my calculator. Excuse me. So I didn't do this wrong for Democrats. So 332,480 Democrats will be in each of those districts. And $5,520 Republicans will be in each of those districts. So if we want safe districts, that's the way to do it. Okay? Or at least safe districts for Republicans in this case. Last case we saw safe districts for Democrats. Now be careful about, making too many inferences about this. Okay? It turns out there's 9 Republicans and 5 Democrats that represent the 14 districts in Michigan. So you might think, oh my goodness, maybe this was gerrymandered, right? Or maybe, something is really awry of somehow in the districts. But remember, and I rounded these numbers, remember that these were my presidential numbers. The numbers that I gave you, Democrat, Republicans, these were, I think I spelled Barack wrong, but these were the presidential numbers. So when I say there's this many Democrats in the state of Michigan, okay, well, you have to realize that just because a person vote Democrat in District 2 on the presidential ballot doesn't mean that in their local representative ballot they're going to also vote the same way. Okay? And all I'm trying to say is percentages matter in this stuff, local issues matter, campaigning matters. So you may have a pretty strong, let's say, Democratic, base in a certain district, and a Republican might come out of it. Or vice versa. You might have a strong Republican base where a Democrat comes out of it. Because, lots of things matter. The candidate themselves and so on and so forth. So just because you see, all of a sudden more people voted for Barack Obama, but we have more Republicans in Congress, well, that may not be means for crying wolf on gerrymandering. It may be just the fact that in certain districts, people were more likely to write Barack Obama in or check Barack Obama's box, but in their local issues, they like the Republican better, right? So there's lots and lots of issues going in here. In fact, I've given a map of the districts in Michigan. Obviously, the UP's cut off here, but they're in green, I believe, as well. So you can look at that and see how things go. Now, since we're talking about Republicans and Democrats and things like that, let's this is a measurement of partisanship per district. Okay? So, again, this is kind of a way of measuring partisanship. It's one indicator of maybe a district being gerrymandered or not. But it's not the ultimate end-all be-all. Okay? So partisanship is basically how strongly a district favors, in general, Republicans or Democrats. Okay? Now, you could do a direct percentage. You could say, well, in the last election, District 15, I'm making this up, so I'll use a district that doesn't exist. District 15 had a 54% of their voters voted Democrat. Okay? And so they are 54%, they're 4% over, the halfway mark, so they're 4% for Democrats. Or maybe another district, let's say District 16, maybe they voted 52% Republican. And they say, well, that's 2% for Republican. So you could do it with a direct percentages idea, right? So this, how many people voted, or what percentage of the people voted for Democrats, what percentage of the people voted for Republicans, and so on and so forth. But it turns out that that's not really the best way to do it, because remember, candidates matter. And what we do is we look at, instead of looking at just the percentages, we're going to look at the percentages compared to the rest of the country. And this is what the Cook Partisan Voting Index does. Okay? It measures how partisan your district is, or anybody's district, compared to the rest of the United States. So here's what you do. You take the last 2 presidential elections. You don't want to take the last one, because one election, can have, a certain candidate who's really popular or who's really unpopular. So what you do is, what I mean by that is in a certain district. So what you do is you take the last 2 presidential elections. Okay, more people tend to vote in presidential elections than in midterm elections. And you look at the average vote for the Republicans and the average vote for the Democrats in the district over the last 2 presidential elections. And then you compare that to the entire average in the United States, again, over the last 2 presidential elections. And the difference between the 2 numbers is going to be the Cook Partisan Voting Index. So let's see how that works in an example. All right. So here are the results of the last 2 elections, and I've rounded everything to the nearest percentage. Okay? So what I want you to do is we're going to look at Michigan's District 4 versus the obviously national average. It's always versus the national average. So national average in 2008, 2012. 2008 was 53% Democrat, 2012 was 51% Democrat. So the Democratic average over the entire U.S. was 52%. Basically, all you have to do is add those 2 numbers and divide by 2. In this case, it's really easy to do that because it's halfway. And so 52% Democrat and 46.5% Republican. Now in District 4, you have to be a little bit careful about this because it starts with a Democrat here, because in 2008, in District 4, the Democrats got more votes. In 2012, the Republicans got more votes in the same district. So in District 4, we're going to average the 50% and the 46% to come up with a 48% Democratic district. Okay. And as far as Republicans go, take 54 and 48, 54 plus 48, divide that by 2, and you'll get 51% is the average for District 4 over the last two elections on the Republican side of things. Okay? So here's what happens. The Cook Partisan Voting Index. Well, you look at the Democrats in this District 4 versus the Democrats in the United States, and you say, well, in District 4, it's 4 less than the regular United States. So we say, well, it's not a Democratic-leaning district, compared to the rest of the country. The rest of the country votes slightly higherly on the Democratic side than does District 4. And so, in one way, we're saying that it's not a Democrat district, or one that votes for the Democratic candidates. Here's the Republican side of things. You take 51%, and obviously it's bigger than 6.5%. In fact, it's 4.5% above that. So the Cook Partisan Voting Index would say that District 4 has a Cook Partisan Voting Index of 4.5%, or some people would just say 4.5 Republican. So even though District 4 voted for a Democrat in 2008, the averages come out to that it's slightly more it's more Republican than the rest of the country. Okay? And by what percentage? Well, by the percentage of 4.5%. All right. So that's how the Cook Partisan Voting Index works. And this is the idea, and this is always going to happen no matter what district that we're in. Obviously, I picked Michigan's District 4 for pretty straightforward reasons. But any of these districts you can do this for and calculate.